Hello and welcome to my B2 cohort internship presentation covering all aspects of the IoT internship and project done at the Ematex. Welcome all. So my name is Nasr Mohammed Abdallah, Head Pursuit Mechanical Engineering at the University of Nairobi, and I'm from Kenya. So let's begin with the session all about IoT. So some of the topics that were covered during the internship were C programming, introduction to embedded systems and microcontrollers, understanding the IoT overview and architecture, understanding the Arduino peripherals and also doing some programming, understanding the PIC-Sim Lab, which is a simulating tool which enable us to perform the programming and simulating the peripherals of the Arduino without interfacing them onto the hard components. And also went ahead and understood about the Blink application, which is the IoT mobile app. And then finally, we are going to discuss about the IoT Home Automation project that we had done. So without further ado, let's all begin with the session. So with the introduction to C programming, we were able to understand that C programming is a general purpose programming language with free formatting format, which is efficient, portable, and also plenty of library facilities. So simply it's just like any other programming, but it's a much better and an efficient programming language with plenty of library facilities. It is commonly used in system software development, embedded software development, or operating system kernel development, firmware, middleware, and driver development, and also in file system development. And some of the keywords that we were able to capture during the C programming lessons were data type, which included the character, the integers, the float, the double, etc. We have the modifiers, we have the qualifiers, understanding the loops like the for, the while, and the do loops, the decision, if, else, switch, case, the jump, like the go to, the break, and the continue, and some of the many others like void, return, and the size of. So with C programming, there are some applications used to code on. So this include the dev C++, and also you can use the online GDP, which is an online compiler that you can use to simulate your codes. And some of the sample of the C codes include like the following. So like the first statement entails that int main is we are calling a function, and then we are declaring the variables, the integer y, the integer x, and whereby we attribute the variable x equal to 0, and then y is incremental of x, and then we are going to print if the value of the x and y, and then we are going to tell the computer or the program to return, and this simply is going to give us that x is going to be 1 and then y is going to be 0. Some of the other concepts that were also understood in the C programming course was about the data types, the conditional constructs, the operators, the arrays, the pointers, the functions, the qualifiers, the strings, and so many others more. So that was all about the C programming that was covered during the internship period. Then let's go ahead to the embedded system. So with embedded system, we were able to grasp much broader knowledge of what are embedded systems. So embedded systems, these are just simply a specialized computing system with chip-enabled hardware and software to perform a specific task or application. So these are just a combination of hardware and software that performs a specific task or application. Some of its benefits is that it has low power consumption, they are of low cost, and they produce high performance. Among the demands is that they must respond quickly to sequences and combination of events, perform multiple separate activities simultaneously, and also handle faults without crashing. So some of the applications of embedded systems, I know you might be wondering what are these embedded systems. So embedded systems, these are simply the hardware chips that are integrated with the software to produce a certain task. So some of the applications can include like the washing machine. So the washing machine is being simulated that when you give it at a timer, so the washing machine needs to calculate from the timer and then be able to perform the execution of the command that you had attributed it. So we can use embedded systems to program and also to apply in different applications, such as the home appliances, during the health and fitness devices like the smartwatches, the wristbands, which can detect our heart rate and so many other things. Also used in automobile during the cars and the bikes, which for example, like the airbag system, we can use embedded system to integrate that whenever there is a collision, the airbag system to burst out and protect the passenger. We have the traffic monitoring lights and systems. We have the smart parking systems, Alexa, and so many other wide variety of applications that are being utilize in embedded systems. So some of the categories of the embedded systems include the standalone. So these embedded systems are of certain different categories. One is the standalone, which simply takes decision on its own and does not require feedback. Like for example, the washing machine, we just switch it on, it just continues to run. And then when it finishes, it just stops. And then we have the real-time embedded systems, whereby these complete tasks within a given deadline of systems. So they are of time-bound embedded systems, like for example, the airbag systems. And then we have the networked, or which simply these are interconnected embedded system devices. Like for example, the routers, the printers. You need to connect from one embedded system to another for them to operate. For you to be able to print a document, you need to connect it to the computer so that you can transfer the document. Also for the routers, you need to connect to the mobile device that you have to the router, and then you are able to interconnect and use these networked embedded systems. Then you have the mobile embedded system, which include the movable or the portable ones, like the smartwatches and the wristbands. And then you have now the general one, the hybrid, which is now getting into the market, which includes that they combine one or of the more category. Like for example, Alexa. Alexa is a mobile one, and also at the same time, it's a real-time one. So it does perform actions. And when I talk about Alexa, this simply is the device that is produced by the Amazon that can communicate and be used at home. When you tell it to play music, and then it does play music. When you tell it to follow you, it can also try and follow you. So some of the major components that are included in the embedded systems are the microcontrollers, or you can use the microprocessor or the system on chip. Also, we have the analog and digital converter, we have the timers, we have the memory, such as the volatile memory, the RAM, and then we have the permanent memory, such as the ROM and the flash memories. And then we have the IO peripherals, like for example, the input and the output, which includes the keypad, the LCD, liquid crystal display, and some of the many sensors. And then we can also include the field programmable gate array, which simply include application-specific IC circuits that can be used to perform certain function. That was all about embedded systems. Then now let's dive deeper into our main agenda, which is the IoT, which simply stands for Internet of Things. And let's understand the overview and the architecture that is behind the Internet of Things. So simply, Internet of Things is the networking of physical objects that combine this embedded technology to communicate and interact with their internal states or the external environment. So simply IoT, these are just devices that are interconnected together with the internet, and more so they are of embedded technology. So these devices are going to communicate and interact with the internal state or the external environment. So what is the architecture, or what is the principle behind the IoT? So the architecture simply consists of three components. One is the device connectivity. We need to connect these devices. And then after connecting these devices, the data that is being obtained needs to be data processed and analyzed. And then lastly, it needs to be presented, because yes, we're analyzing the data, but we need to have a presentation of the data, the output of the data. So simply, we have the IoT devices. These can include several devices. You can be, let's say, for example, like for the home automation, which you're going to look into, we might be having our air conditioner, we might be having our refrigerator, we might be having our heater and cooler in the house. And then these devices need to communicate to each other via a certain gateway or via a certain output point, that this output point is going to connect to the internet. And then this output point is going to connect to the cloud, and then the cloud now is going to analyze and data process the information that it's being received. And then from the other end, after analyzing, it needs to respond back to the consumer, whereby it needs to present the data in case of any hitches or any information that the consumer wants. So for example, you might be at home out of work, and then you remember that you need to procure some items for your fridge. So you can just tell the IoT application to just tell you what is missing from your smart refrigeration system. And then the smart refrigeration system is going to send you a message that, let's say you have milk that needs to be purchased. So out of your way back home, you're going to get into the supermarket and buy some milk, and then go back home readily available, which enable you to work wirelessly without you being at home, and be able to analyze and get that data while at the comfort of your place. We also went ahead and understood, for us to perform the IoT, we need to program. and we need to connect some devices. So with this, we were able to understood what is Arduino programming and also understand some of the peripherals that are used in Arduino programming. So what is this Arduino that we mostly hear of? So simply is an open source platform used for building electronic projects. So Arduino consists of both a physical programmable circuits board, which is on our right, often referred to as the microcontroller, which simply is just the small black devices, the long devices around here, the microcontroller, but we call all of these components embedded with other devices on top, like the op amplifier, the power jack, and so many other devices on top. But all these constitute the hardware Arduino tool. And also we include a piece of software, which is, we call it the IDE, the integrated development that runs on our computer, which enable us to write and upload our computer code onto this physical board. So this is the Arduino IDE, which enables us to write our program, and then we are going to load the program onto this microcontroller, onto our Arduino, and then we are able to interconnect and communicate with our devices. So some of the devices or the peripherals that we can use and interconnect to the Arduino board include the LDR, which simply stands for light dependent resistor, which is a light sensitive device used to indicate the presence or the absence of light. And here it is. It can detect the absence or the presence of light and give in terms of resistance. We have the LED, the light emitting diode, which emits light when the current flows through it. And then you have the LM35, which simply is a temperature sensor having an analog output voltage proportional to the temperature. So simply this helps us to detect the amount of temperature. And the amount of temperature that is being fed is equivalent to the proportional voltage that is going to compute inside the Arduino board. And then lastly, we have the CLCD, which simply is a character liquid crystal display, which is a flat panel display which uses liquid crystals in its primary form of operation in displaying our characters, and so many other peripherals. So what are some of the Arduino commands that we can use in our Arduino programming? So some of them include the analog read, analog write, digital read, digital write, serial.begin, lcd.int, lcd.print, and so many others, depending on the functionality and the application of your code. So for example, like the analog read returns a number between 0 and 1023, which that is proportional to the amount of voltage being applied to the pin. So we use analog read to compute data or to read data, and that data that you're going to read from the analog channel, it's going to give us in form of from 0 to 1023. And then the Arduino board is going to use the ADC to convert into the relevant voltage and give us the output. And then we have the analog write, which simply we are going to write into the device. Like for example, the sensor, we are going to write an analog value of ranging from 0 to 255 onto the pin. Digital read, we are now using the digital pin devices, which are either high or low, which we are going to read the value from a specific digital pin. Either the LED is on or either the LED is off. We have the digital write, whereby we can write a high or a low value to a digital pin. Then you have the serial.begin, which we are going to start the serial communications. LCD.initialize, which are going to initialize the display of the LCD. LCD.print, if we want to print onto the LCD, and so many other commands. So some of the types of Arduino communication protocols that we might be using in our program, which includes the serial communications, which utilizes the receiving and the transmitting pins onto our board. And then we have the I2C, or the two-wire interface. So whereby for this two-wire interface, we connect the two boards together by utilizing the serial clock and the serial data line. So we use this serial clock and serial data line to communicate between these two devices. For the serial communication, we are using the receiving port and the transmitting port to communicate between these two devices. So we have two types of communication protocols in our Arduino board. We have the I2C, which simply we're interconnecting two-wire interface, whereby when we connect the serial clock of this board, we connect it to the serial clock of the other board. And the S serial data line, the same thing to the serial data line on the other end. But for the serial communication, is a two-way thing, whereby we connect the receiver and the transmitter onto the different boards. Okay, much of the Arduino programming. Now let's dive on what software or program that we are going to use to simulate our programming devices and also the Arduino program that we had written down. So we are going to utilize the PixSim So what is this PixSim So we say that we are not going to use the hardware connections, but Nowadays, we are having the advantage of the real-time softwares that are going to simulate and interface our program and see their action before actually interfacing with the hardware devices. So PiximLab is a real-time emulator of development boards with MPLab X or the FVRGDB debugger integration. So simply, it supports Pixim microcontrollers and so many other AVR microcontrollers, which enables us to simulate our program and simulate our peripherals on how they are going to actually respond to the program that we had written. So on our right is our Pixim Lab, which similarly looks like the Arduino board. We have the microcontroller, the Atmega, we have the pins, we have the serial clock, the serial data line, we have the transmitter, we have the receiver, we have the up amplifier, we have the analog pins, we have the ground, the voltage, and so many others, which exactly look like the Arduino board that you are going to connect it to when we want to simulate it on a real-time basis. And then with the Pixim Lab, we are also able to obtain some other peripherals like the CLCD, like the LED, the LDR, the Ethernet shield, and the temperature system, and so many other devices that we are going to interface from this microcontroller board with the Arduino and to the peripheral devices, such that when we load our program, it's going to interconnect to the peripherals and see how it's going to respond and react, as if we are in the real interfacing of the hardware components. Then we are now going to utilize the Blink app. Since we are involving IoT, it's not just about programming, but it's also about interconnecting these devices and also getting output out of these devices, whereby we are going to interconnect them via the internet. So we are going to use another application known as Blink. So Blink is an IoT platform for iOS and also Android smartphone that can be used to control Arduino, Raspberry Pi, Node MCU via the internet. So these are simply just some other microcontrollers, but our main focus is going to be on Arduino. So this application is used to create a graphical interface or the human machine interface by compiling and providing the appropriate address on the available widgets. So it can control the hardware remotely, whereby we can control the sensors, we can display the LCD, we can use to display sensor data, store the data, visualize it, and also do many other stuff using the Blink control. So let's say, for example, we want to write our name onto the CLCD. We can just use the Blink application to control what is being displayed and what is not being displayed. We can control the sensors, either we want to increase or to reduce the amount of input into the sensor, and so many other applications that we can control wirelessly via the Arduino boards connected to the hardware devices. So, into the bigger picture, all about IoT. Now we're going to simulate a real-time project, which is the IoT Home Automation project. So in this project, it is entailing on how we can control the garden home lights at home, also control the temperature of our house, also control the inflow and outflow of water in our tank. So simply with our project, the Home Automation project, we are going to simulate our home into behaving and into connecting it wirelessly so that we can be able to control it. So let's say for our project, we are going to control these three devices: the garden home lights, the temperature, and also the inflow and outflow of our tank, and also give some commands onto the recommendations that we want out of each of the component. So let's say, for example, we want to control the outflow and the inflow of our water. We can give it some certain characteristics and command. Let's say we want our tank not to be fully formed or fully filled with water. We can just say it, let it be at a minimum range of 3/4 of the tank. We can also give the commands and let it tell us by giving us a warning that our tank is almost full, so that it doesn't get filled up and then later we need to switch it off manually. But we can use IoT to give us a warning or a message and actually do a certain command when that warning is being reached, which we are simply going to look into. Also, through the Blink IoT application, the Pixim Lab Simulator, we are going to simulate our home automation project, whereby the LED, the temperature system, and the serial tank are going to resemble like in real life. For the LED is going to resemble the garden lights, because the LED, these are just devices when connected to power, they just emit some light. But now we are going to emit these LEDs and to behaving like the garden lights, such that when there is available sunlight, they emit light. they don't emit light, but when there is no sunlight, they emit light. Also, we have the heater and the cooler in our home. So these simply are going to be substituted the temperature system, and also the serial tank that we're going to use by the PICSIM lab is going to simulate the water tank in our real-time application. So the CLCD then is going to act like the dashboard used for displaying the events, also the temperature. And then on the widgets on the Blink IoT app, such as the button widget, we said that we can simulate our program using the Blink. We can switch on and off the devices that you want wirelessly. So in the Blink app, we have these devices or these components known as the widgets. So we can create several widgets like the button widget, the gauge widgets, and the terminal widgets. Whereby for the button widget, are going to control the heater and the cooler, the inlet valve and the outlet valve. So with the button widget, we are going to make it like a switch on and off. So we want to control the heater on, we just click on the button. We want to control the cooler off, we just click on the button. The inlet valve, we just hit the button. Same with the outlet valve. With the gauge widgets, we are going to use to display the temperature and volume of our water in the tank. So let's say we want to understand what is the temperature of our home. We are going to utilize the gauge widgets. And lastly, we have the terminal widgets, which are going to display the notifications whenever a threshold is crossed. So let's say if a certain temperature limit is being crossed, a temperature limit of 35. So it seems that it's getting too hot. So we need to give us the notification and be able to understand that the temperature are now beyond 35 degrees. Hence then, we can now use the button widget to put on the cooler button so that it can start and cool off the room. So without further ado, what are some of the requirements? So this is simply a simulation of how the interfacing between these devices work. So we have our home, which has the garden lights, which has the water tank, and also which has the heater and the cooler. And then these devices are in communication with the PICSIM lab, whereby this PICSIM lab, which is the Arduino microcontroller, which has the program, it is interconnected with the peripherals that are interconnected together, and then they are being interconnected via the Blink IoT app. Then this Blink IoT app, we have the cloud server and also we have the mobile app. So we can use either the mobile app to control our devices wirelessly while at our convenience, such that let's say, for example, a terminal is brought to us that the inlet valve has reached a certain threshold limit, that our tank is almost getting full. So I can use the mobile app to switch off the inlet valve from emitting more water into the tank. And such that this communication goes back to the cloud server, and then the cloud server communicates with the Arduino peripherals. And then these Arduino peripherals is going to interface with the hardware devices that are interconnected, and then are going to stop the inlet valve from continuing emitting much of the water into the tank. So what are some of the requirements of our project? One is that we need to read from the LDR sensor. As we had said, this is a light dependent resistor which reads the light intensity. Based on the reading from the LDR, vary the brightness of the LED, which resembles the controlling of the garden lights based on the availability of sunlight. Then we are going also to read the temperature of the sensor using the LM35, which is the temperature sensor, and display it on the LCD, which simply is going to tell us what is the temperature of our room. And then also we need to control the temperature of the system by turning on and off the heater and the cooler using the Blink IoT mobile app. So let's say if it's too hot, we need to switch on the heater. Too hot, we need to switch on the cooler. If it's too cold, we need to switch on the heater. So which simply is going to enable us to have a display on the CLCD and be able to switch on and off using the Blink IoT mobile app and be able to control the temperature of our home. Then we also need to read and compare the temperature with 35 degrees. So if the temperatures are more, we need to go turn off the heater and also send a notification and display the same on the CLCD. Then on the part of the tank and the volume of water, we need to read the volume of water in the tank through serial communication, which is using the transmitting and the receiving, and also display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and the outlet valve by sending commands through serial communication. Also display the volume of water in the tank on the LCD. So if the volume of water is going to be less than 2000 liters, turn on the inlet valve and fill it in the tank. And also send on the notification to the Blink mobile app and display the same on the CLCD if the tank reaches 2000 liters. So this is how it's going to look like. We have our display on the CLCD. We have our terminal window, which is going to give us our messages, and then you have our Blink IoT mobile app that is going to give us an input and output and control wirelessly using our Blink mobile app. So for example, we can switch on the inlet control, we can switch off the outlet control. We are able to view using the gauge widget by viewing the amount of volume of water that is in our device. Also, we can control the heater on and the heater off. Like for example, if the temperature are normal, we can, and they are still rising, we can switch on the cooler to cool off the temperatures. And if it's getting too cold, we can switch on the heater, and then when it reaches to a certain threshold like 35 degrees Celsius, it's going to switch on the cooler and switch off the heater. So without much ado, let's jump straight into the practical. So allow me to open my application. So first and foremost, I like to open the Blink dashboard. So for me, my devices, I've got the home automation project. So simply I have my web dashboard. So instead of using the Blink mobile app, I'm going to utilize the web dashboard. So simply with the Blink, if you are using the computer, you can also control it seamlessly using the web application platform. So as you can see, the home automation is telling me that it is offline. And I have all my button controls that I had put in conjunction to what I'm going to utilize and need in the program. And then I'm going to open the PixSim Lab simulator, whereby it's simulating my Arduino. And then I'm going to the modules and opening the spare parts, the platforms that I need. And then also I need to control my tank. So I'm going to the tools and then going and opening the serial remote tank. So as you can see on my web dashboard, now it's connecting wirelessly using the IoT, and it's telling me now it's back online. So I'm going to connect with the ports. So if my tank is connected to COM1, I can say connect. It's telling me that is an error because the PixSim Lab has picked port 1. Yes, COM1. So I need to connect it to COM2. So when I connect it to COM2, when I say connect, it's going to display the information that I need. But before that, I need to reset my dashboard. So first and foremost, as you can see, my tank is being filled in. And as you can see from the CLCD, it's displaying the volume. And also on my web application, as you can see, the tank is being filled in. And also on my application web platform, it's telling me how much data is being fed in. And also you have the terminal, which is displaying that volume is less than 2000 and is turning on the inlet valve. So when it reaches to a certain limit, as you can see, the inlet valve automatically switched off itself. And then it's telling me my tank is 3000, it's fully tank, and then it's turning off the inlet valve. So if I want to turn on the outlet valve, I can just switch on using the web dashboard and tell it outlet valve open. And as you can see, the outlet valve is removing some water from my tank. And as you can see from the web dashboard, you can also simulate with different colors. So since I had set a command that when it reaches 2000, it needs to stop the outlet valve. So as you can see, the outlet valve switched itself off and turned on the inlet valve. So simply, this is the controlling of the simulation of the tank. Also, we can simulate the LDR. So like for example, with the LDR, it's going to simulate the garden lights. So with the garden lights, for example, we are having much resistance. It means that there is no light. But if there is higher resistance, there is less light. If there is less resistance, more light. So simply, it's indirectly proportional to the light with the resistance. So if there is high resistance, less light. So for example, if you're going to put it off, it's showing that there's less resistance, hence there's no light. So there is light. So simply the sunlight is available and such that the LED are going to switch themselves off. But if the resistance is high, it means that there is no sunlight such that the LED needs to switch on. So simply if the light intensity is varying, and as you can see, the valve is adjusting itself with the LDR, you can see that the intensity of the LED also varies. So when I put it off, it means that there is low resistance, simply there is more sunlight out there. Hence, our LED or the garden lights needs to switch off. But if there is high resistance, it means that there is less sunlight and it is getting darker in our environment. Hence, it needs to switch on our LED lights. Okay, that's it on the garden lights. Then getting back into our temperature. So with our temperature, let's say at the moment it's reading a temperature of 27.34. It's a bit hot or it's a bit warm. But let's say we want to turn on our heater. So when I simply turn on my heater, as you can see, the temperatures are going to simply rise. So as you can see, it's displaying heater on and the temperature is still rising. And as you can see also on the dashboard, the temperature is rising. But we put a limit onto 35 degrees. So when it almost hit the temperature of 35 degrees, our heater automatically turn off. So simply, if the temperature is still at 33 and it's getting a bit much hotter, yes, it's going to cool itself down due to thermal equilibrium, but if you want to cool it faster, we can also switch on the cooler. So as you can see, if I'm switching on the cooler of our home, it's going to cool our temperature drastically to the temperature that we need, which is 27.34. As you can see, it has drastically come down to 27.34. Okay, that's it on our project, and that is our home automation IoT project. Utilizing the Blink IoT application and utilizing the PICSIM lab in loading our program through the Arduino IDE and then simulating the peripherals and connecting our devices. Thank you.